This lesson is for FST, lesson 6.6 on conditional probability. Right away we're going to jump into conditional probability's definition. You'll see a vertical bar, and the way that you say that bar is just like what's written here on the lesson. Conditional probability of event B given event A is calculated as the probability of A intersect B, remember that intersect means where they overlap, divided by the probability of event A. So the order that these are in does make a difference. The first thing that's mentioned is going to be part of your numerator, and the second thing that's mentioned is going to be the denominator. So let's start with a situation that students were working with yesterday on contingency tables in lesson 6.5. And we're going to compare this now to a conditional probability setup. So we have the percent of people that survived the numbers of people that survived and died in the Titanic based on what class they were in and whether or not they survived. So what's the probability that a second class passenger survived? So this time we're working with the probability as opposed to yesterday when we did percents. So remember that the first thing that's mentioned is going to be your denominator, so second class passenger. So we're going to call that event A, and we're going to find out what that number is. So a second class passenger is going to be the 118 and the 167. So that's going to be on the bottom. And then a second class passenger that survived, that's going to be the intersection of the two. So that's going to be A intersect B. So the intersection is where we have second class and survival crossing each other. So that's going to be the 118. So notice that when you set up your fraction, you've got some of the numbers that are being used twice, because A and the overlap of A means that that number is going to be there more than once. So when you do the math here and add on the bottom, you're going to get 118 over 285. And when you divide there, you're going to get about 41%. So that's the real basics of conditional probability. It's pretty much the same thing that we did yesterday with the percents, only now we're calling it a conditional probability versus a percent. So let's keep that formula in mind as we do some further work with conditional probability. We're going to go through the first example in the textbook. First, let's just read what it says. An article in the Journal of American Medical Association in 1997 reported that when people go to the doctor's office with a sore throat and think that they might have strep, 30% actually have strep throat. It noted that a current test for strep throat was 80% accurate if you have strep throat and 90% accurate if you don't. What is the probability that a person who receives a positive result from this test does not have the disease? We're going to try this problem in two ways to illustrate conditional probability. First, we're going to start with a table. And in our table, we're going to have the fact that you're going to test positive or test negative when you go to the doctor. And let's talk about that for a moment. When you test positively, that means you have strep throat. So the positive test would mean you have the disease that you're working with in the problem. A negative result means you don't have the disease. So you could be going to the doctor and being tested positively or negatively. The other thing that's occurring is you either have strep throat or you don't. So this is where our whole idea of complementary comes into play. Either you do or you don't. So either you have it or you don't, and either you're going to be testing positively or negatively for having the disease. So hopefully students can realize there that those are two different things, having it versus the test revealing that you have it. So we're going to go ahead and fill in a lot of these percentages and then do some calculating here. So 30% of the people actually have strep throat. So when you have strep throat, you need to have that number indicated. So then the fact that you don't have strep throat would be the complement to that. 70% of the time you don't. So that takes care of our first number. Then the test for strep throat was 80% accurate when you have strep. So it's 80% accurate, meaning it's going to say that it's a positive result when you have the disease. So we're going to multiply that by 0.8. The complement to that is you have the disease, but it's not accurate. So the complement there is going to be the 0.2. So 80% accurate when you have strep throat. So it's going to give a positive result when you're sick. When you're sick, 20% of the time it's going to say that the test was negative. So we've got that number figured out. Next is the test is 90% accurate when you aren't sick. So a 90% accuracy when you're not sick means you want a negative result when you're not sick. So when you don't have strep, you want a negative result indicating that you're not sick. So the 90% accuracy goes with when you're not sick, you would like a negative result. And then its complement is going to go up here at 0.1. So now you'd go ahead and quickly calculate all of these multiplications, and those are going to be the numbers that we're going to use. So we have 0.24, 0.06, 0.07, and 0.63. Before we move on here, let's just talk real briefly about the positive versus the negative. When you're not sick, you want a negative result because otherwise, if they tell you that you are sick when you aren't, they're going to give you a medicine that you don't need. So it's important to have accurate results when you're sick and when you're not sick. So that's why those numbers are different. So now let's look at the question. What is the probability that a person who receives a positive result, that's event A, that's going to be our denominator, does not have the disease? So a positive who is not sick. So that's our intersection. So positive test result, that is this row here. So the bottom of my fraction is going to be 0.24 and 0.07. Positive results is those two numbers. And then on the top, I want the intersection of a positive result but does not have the disease. So between these two, which one is the not sick one? That's the 0.07. So when I divide that out, I get about 22.6%. Yesterday when we did 6.5, we were using rounding to the tenth, so we're just going to be consistent there. If they ask you to round to something else, obviously you would pay attention to that. Let's try this problem again, this time using a tree. I know some kids are more comfortable with the tree, so I want to show you the question again using that method. So the question begins with talking about people who are sick or not. So we're going to start with that as well. So we're going to make a tree here. And try to give yourself lots of room here to do this. First we're going to say you have strep. And then we're going to say you do not have strep. You could also be generic here and say sick versus not sick. From there we're going to list out testing positively and testing negatively. And again, try to line up your things as you go here. So you kind of want things to be lined up vertically as best you can, depending upon how much room you have. So remember, the people who are sick, the people who have strep, that happens 30% of the time. So then the complement to that would be 0.7 down here for do not have strep. When you test positively and you are sick, that test is accurate 80% of the time, so that's a 0.8 here. Complement to that would be 0.2. So I think for a lot of kids when they're setting up the tree, the complements are a little bit easier to see here versus in the chart. When you're not sick, it's 90% accurate. So when you're not sick, you want a negative result, so we'd put the 90 down here with the negative test result, and the complement to that up here at 0.1. The only tricky part about the tree here is that you do need to multiply the branches together, and those are the values that you're going to be using. So you're not going to be using the numbers here, you're going to be using the results. So you do need to go ahead and continue to multiply here. So we're going to get the same numbers that we got before, just we're going to list them out here at the end of our tree. So we're still multiplying 0.3 times 0.8 to get the 0.24, 0.3 again times 0.2 to get the 0.06, 0.7 times both of these to get our answers over here, 0.07 and 0.63. So now let's talk about where we would get our answers from. So we're still answering the same question, so let's go back and take a peek at it. Positive test results that do not have the disease. So positive test results are going to be that number and that number. Those are where the pluses are. So that's going to be your denominator. And then do not have the disease has to be one of those two. Does not have the disease is the bottom, so that's going to be the 0.07. And we should get the same result there. And let's do one more thing here. Let's write out in words what we were trying to find. So on the top we were doing a positive test result and do not have strep. So that's our intersection, and we were dividing that by a positive test result. So that's where we got the two numbers there for the positive test result. There's two of those, but the positive result that does not have strep is only the single number. Let's try another question, and this is going to be example 2 in your textbook. And again, we'll try this again with a table and a chart. False negatives is something that students need to understand. In cases such as cancer, where a disease can be fatal and prompt treatment is crucial to the patient's survival, false negatives are particularly troubling. So let's talk about a false negative for a moment. That means they are sick, but the test is a negative test, meaning they believe at the doctor's office that you're not sick. So you are sick, you need treatment, but the test is negative. What does that mean? That means you get no treatment. So a sick person getting no treatment is of concern. That's what they're talking about here. So let's look at an example of when a false negative would come into play. Suppose all patients are tested for a serious disease, so we're just going to call that person sick, and it's estimated to be found in 0.5% of the people. Suppose also that the test accurately spots the disease 98% of the time, accurately indicates no disease 95% of the time. What is the probability that a negative result is a false negative? Again, let's do the chart first, and we'll write out some notes here as we go. So when you're setting up your chart, I usually like to do the positive and the negative testing on this side, and then the sick versus not sick here. So sick, not sick. Disease, no disease would be another way to do it to be a little more accurate to the question itself. And then I usually go through and I pick out the first number that's given. First number that's given is 0.5%. We're going to list that out as a decimal. So all patients are tested for a serious disease, and it's estimated to be found in 0.5% of the people. So 0.5% of the people are sick. So I'm going to put 0.005 are sick. Remember that the sickness here is a column, so I need to write that number twice. That number's finished. Now you go and you get tested. The test accurately spots the disease 98% of the time. Remember that a positive test result means you're sick. So 98% of the time when you're sick, you get a positive result. So that's 0.98 here. The complement to that would be that you got a negative result when you were sick. So the complement there would be 0.02. Together, the 98 and the 2 have to add up to 100%. Now let's do the 95%. Accurately indicates no disease 95% of the time. So when you're not sick, you get a negative result, is what that means. A negative result should mean that you're not sick. So when you're not sick, you want a negative result. So that should be 0.95. And then the complement to that would be up here at 0.05. Now I neglected to do an item from back up here when we were doing the 0.05%. The complement to that would be over here. Complement to 0.005 is going to be 0.995. Pardon me for forgetting that earlier. So then accurately indicates no disease was this number, the 0.95. When you're not sick, you get a negative result. And then the complement to that is that you get a positive result when you're not sick. So now we need to do the multiplication on all of these and get our new results. So here I'm going to get 0.00249, 0.0001, And I'm just going to pause the video here and fill these in. You don't need to hear me read those off. So now let's answer the question. Keep in mind that there was a mistake here on this number that has been changed. What is the probability that a negative result is a false negative? First thing listed here is negative result. That's going to be event A. And the negative result that's a false negative, that's going to be the intersection. So I want to put that you have the disease, but your test is negative, divided by a negative result. So you have the disease, but you get a negative result. So that's sick but negative. That's going to be 0.0001 on top. And then on the bottom, all the negative results. So that's the 0.001 that we already used and the 0.94525. Again, make sure you add together first and then divide. So we're going to get a super small number here. When you go ahead and divide that out, you're going to get 0.0001 again. Change that to a percent by moving the decimal point 2 places, so you get about 0.01%. Now if you were a patient, that would be really good news. You're only going to get a false negative 0.01% of the time, which is a super small percentage, and that's a good thing. You don't want false negatives to be super high because then that means you're sick, but you're not going to get the treatment that you want or need. Let's do this question again with a tree, and then we'll be finished. So let's try it again. Remember that there's two things you're going to say at the beginning, two branches, sick and not sick. Let's fill in the percentages as we go. The sick people were found in 0.05% of the time, so that's 0.005. The complement to that is that you're not sick, 0.995% of the time. If you didn't know that number, you would just do 1 minus 0.005 to get this number here. From there, you're going to get tested, positively or negatively. So the 98% number that's given is accurate when you are sick. So you get a positive result when you're sick. Accurately, that would be 98% of the time. So then the complement to that would be 0.02. Accurately indicates no disease 95% of the time. So when you're not sick, you get a negative result 95% of the time. Complement to that 0.05. Again, remember here you do need to multiply. So we'd multiply here, 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 and here. So when we do that, we get same numbers that we got before. So now let's look for the false negatives. The negative results are here and here. Which one is the false negative? A false negative, remember, means you are sick, but the test says you aren't. So that number is going to go on top, and the numbers together are going to go on the bottom. And we should get the same result there. I think for a lot of kids it's easier to see the negative results in the tree versus the chart, but know that both are perfectly fine ways to answer these types of questions.